Hello, hello. Hey, long time no see, right? How are y'all? Hope you had a great weekend. Hope all is well. So, I remember we left off adding fractions, right? Ooh, what were those fractions? 4/7 and 3/9 or something like that? So, I believe we left off adding fractions. But as I was stating, that I forgot to go over the most important part when it comes to adding fractions, and that is multiplying fractions. It's presumed that you already know how to multiply fractions when you go to add and subtract fractions. So real quickly, let's talk about multiplying fractions because that's going to be one of the more simpler ones for you to remember. And when we're multiplying fractions, and you know, I haven't found out the best way to kind of not turn my back. I also noticed that. I'm like, ooh, you turn your back on the camera when you're writing on the board. Well, I have to write on the board. But hopefully you see it. And the cool thing about this is that it's video. You can fast forward, you can rewind, you can pause. So I like it. I think it's okay. And like I said, this is just for you guys. I'm not trying to do anything fancy, but I know I get a lot of questions, and so this will be something for you to go back and use as a resource, right? Yay! So, again, when it comes to multiplying fractions, the rule is numerator times numerator and denominator times denominator. And the cool thing is, like, when you're multiplying fractions, that's where you get that reduce. I know everybody's like, oh, reduce, 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 but it's only when you're multiplying, and I guess dividing fractions as well, since multiplying and dividing are inverse of each other. But that's when you get to do that reduce ahead of time, not when you're adding and subtracting. So real quick, let's just say we're multiplying, throw some out there, 3/5, and it's going to be times, let me find something that works, we'll say 10 over 39. So technically we would do numerator times numerator, 3 times 10, that would equal, don't add that equals if it's not there, right? That leads to 30. And then 5 times 39. So we'll come off to the side of our paper. All right, 39 times 5. 9 times 5 is 45. Carry the 4. 15 and 19, right? 195. And then we could reduce by the common factor because they both have a common factor of 5, right? And reducing is, remember I told you there's only 4 mathematical operations, and everything you do is a form of one of those 4 mathematical operations. So reducing is like dividing out. We're going to say what common factor do they have, what's a number that goes into both of these evenly without leaving a remainder, and we know from our rules of divisibility, and if we don't, we should look those up and have those on the side, that 5 is a factor of each of these. And that 5 goes into 30, 15, or how many times does 5 go into 30? 6 times. And how many times will 5 go into 195? Well, that's going to be 39 times, I believe. Right? And then we're like, ooh, are both of these do 6 and 39? Does that have a factor of 3? Yes, 3 goes into 6 2 times, and 3 goes into 39 13 times. So 3/5 times 10 over 9 is going to reduce down, actually it's going to be 30 over 195, which is the same value as 6 over 39, which is the same value as 2 over 13. But again, if we're reducing, we're going to pull out that common factor, right? So we know 5 goes into 5 one time, 5 goes into 10 two times, 3 goes into 3 one time, and 3 goes into 39 13 times. So now, because we've reduced ahead of time, we end up with, can y'all see? We end up with, I'm trying to take it over here, take my little arrow and say, we end up with 1 over 1, right, times 2 over 13, which of course, and I always put this equals, don't I? 2 over 13. So you can see how reducing comes in handy. But don't force yourself if you're not comfortable with it. You will eventually get there. Notice you have the same answer either way you take. So that's the cool thing about math. Math rules don't ever change, no matter the level, okay? And there's always more than one way to do things. And so that's why when you're in class and you're like, oh, I can do it like this. Why do you want me to take all those steps? All those steps are necessary when you're attacking other concepts. That's why, okay? So don't discredit these little steps that we have in there. Try to get familiar with them. But, you know, whatever works for you in the beginning, if you're comfortable with reducing ahead of time, go ahead. If not, then you can reduce afterwards. So, again, that's multiplying fractions. Numerator times numerator, denominator times denominator. And you have to know how to multiply fractions before you can multiply, or before you can do any other operation with fractions. Because adding and subtracting is going to cause you, or require for you, to find a common denominator. And when you do that, when you build equivalent fractions, remember equivalent fractions? We briefly talked about those. Fractions of equal value. So like 1/2 is the same value as 5/10. This is the same value as what? 10 over 20. They all represent the same value. They're equivalent fractions, fractions of the equal value. So when you are adding and subtracting, again, you have to know this, multiplying, how to multiply fractions. And I think most of you kind of remember, and you just maybe not remember the terminology for it. So that's that part. Now that I know that you know how to multiply fractions, we can continue adding our 4/7 and 3/9. And some of you might be like, wait, well, can I reduce 3/9? And actually you can. Before you start adding, since 3/9 is a fraction by itself, could you reduce that before you added these two? Yes, and if 4/7 had a common factor, then you could also reduce that. However, we're looking at the 3/9, and so you could rewrite 3/9 as 1 over 3, making it a little bit smaller bit of fraction to work with, right? Then you don't have to find so many. You don't have to list your factors so much because you already know 7 times 3, was that going to be 21? But we'll do both of it up here so you can see, right? So we already determined right here, remember last, I believe we selected 63 as our greatest common denominator. And so I believe we left off at rewriting this because we were multiplying this one times 9 over 9, and I was talking about how 9 over 9 is 1. We multiplied this one by 7 over 7 because that is 1, and I was saying that that's just like changing a dollar bill, going from a dollar bill to 4 quarters, or if you give someone, 10 dimes and they give you 4 quarters, or they give you a dollar bill or something like that. That's all we're doing. Where the value's the same, we're just changing the way it looks and for the use that we need it for. So up here, I'm gonna move this down. I'll put that back in a minute. So we know we have 36 over 63 plus 21 over 63. And again, the rule for fractions, remember when you're adding and subtracting them, the denominator, the amount that makes up the whole, that stays the same. You're only adding the numerators, adding or subtracting the numerators depending on what the operation asks for. In this case, we're adding, so we're gonna add our two values, 36 and 21. It's gonna give us what? 57 over 63. Excuse me. And then we look to see, is it reducible? Do they have a common factor? And because I know my rules of divisibility, I know that adding 5 and 7 gives me 12. 12 is a multiple of 3, therefore 57 is divisible by 3. You're like, what? It's when we go over the divisibility rules. When we do that, or if you have that, just throw that in the chat, in the comments. I've turned on comments now, so you can make all the comments you want. Hopefully they're nice. If you don't like the videos, then don't watch. But yeah, you get 57 over 63. It's the rules of divisibility. So I know that at the smallest, the value 3 is a factor of each of those. So I will reduce these by 3. 3 goes into 57. 3 goes into 5 once. 3 goes into 27 19 times. And 3 goes into 63 21 times. So our final answer is 19 over 21. Now, for those of you that are like, okay, you said we would get the same answer if it was reduced. Let's see it. I'll definitely show you. So we had that 4 over 7, and we reduced this, remember? We reduced the 3/9 down to 1 over 3 plus 1 over 3. Finding our common factor.